All right, so this one we're going to talk about parabolas. Not much to say about as far as the introduction here. We have the same idea with the minus h to shift the x direction, and then the minus k to shift in the y direction, same as what we had before. So let's look at this first example. We have x squared minus 4x equals 8y. Where'd it go? There we go, minus 28. All right, so this one, we actually need to do something called completing the square, and I'm going to post a video where we'll go through completing the square. In case you don't remember from algebra how to do this, but we'll teach it here, but go into more detail in another video. So basically, what we need is we need to add something so that we can factor this trinomial and get a perfect square, and then whatever we add here, we have to add over here. Since it's an equation, we got to keep it balanced. So the way to get what we need here is you divide that middle number by 2 and then square it. So -4 divided by 2 is -2, and then -2 squared, of course, is 4. So we have 4 there, so then we got to add 4 on this side. So now we can factor this. That will factor into x minus 2 squared. We can get 8y minus 24 on this side, and then we're going to factor out the 8. And we have 8 times y minus 3. And so this tells us that the vertex is 2, 3. So you change the sign on the -2 or the -2 there, x minus 2, and then the y minus 3, change the sign on both of them. And so we know that this is going to open up because we have a positive coefficient there. And we know that it's going to, well, we know it's going to open up because the x is the squared part. So it's opening up or down. We know it's opening up because of the positive coefficient. So that tells us, if we start this sketch, so there's our vertex, and then we're going to look like that. And so now how do we get the focus? So we know that 8 is going to equal 4p. So back up here with our formulas, this coefficient in front of whichever part is not squared, so in this case the y, that will equal 4p. So that tells us that p equals 2. And so when we were doing these in 11.1 and we're centered at the origin, all we did was just move up. So the focus would be the y coordinate would be 2, and then the directrix would be y equals -2. We move down that much. So same thing here. We're just, here is our vertex, and then we're going to move up to, there will be our focus, and then we're going to go down to, and there will be our directrix line. So the focus, so you have the vertex is 2, 3. We're going to add 2 to the y. And our focus is at 2, 5. And then the directrix is going to be at y equals 1. So you subtract 2 from there. And that's all there is to it. So so there's the graph, there's the focus and the directrix, and there is the vertex. So same idea. If you're comfortable with the last few sections where we're doing the basics, then this is just really a little bit of adjustment to get these shifted. So now this one, we have find the equation of the parabola where the vertex is -5, 8, and the directrix is y equals 4. So I would suggest you at least start this. So -5, 8, and then the directrix is at y equals 4. So that is 8, -5, and then that is at 4. So that must mean that we're opening up like that, and then the vertex, or the focus, will be there. And so now let's see if we can figure out what this equation is. So we're opening up. That means that the x is going to be squared. We're subtracting the -5, and then we have 4p, and then y minus 8. And so now we can figure out what p is. P is just going to be the distance from the vertex down to the directrix, which is 4. So x squared. So we go from 8 to 4. So p is 4. So 4 times 4, and then y minus 8. And of course, that will give us x plus 5 squared equals 16, y minus 8. And that's all there is to it. All right. So next one we'll look at hyperbolas.